Right. Today we are starting with mechanics paper for June 2014. This IAL paper. Right. Okay. Initially, let's start with this. Mention here as two smooth balls of A and B have mass 0.6 and 0.9 kg respectively. Right. So I'll just mark these two objects A and B. A and B, where A is 0.6 kilogram and B is 0.9 kilogram. Right. Okay. They are moving straight towards each other in the opposite direction on a smooth horizontal flow at a collide directly. So in this case, they have given this condition. Smooth horizontal flow means there are no external forces, because this is the principle of linear momentum conservation question. For that, we couldn't get any kind of external forces for that. Immediately before the collision, speed of A is V and the speed of B is 2 meters per second. Right. Immediately they are moving straight line towards each other. So you can say this is 2. The speed of A, so this is the before the collision in this condition. Over here, after the collision, the speed of A is 2 meters per second immediately after the collision, and B is brought to rest by the collision. So in this case, now we have a small doubt. Now, to which way this A comes with? So B become rest. So here is V is equal to 0. So if this is rest, you definitely it cannot come like this. It cannot jump like this and it can travel. It's not possible. Therefore, obviously what happened here, this should be to the other way around. And we should go to this side. That is the initial fact we need to understand 2 meters per second, right? Find the value for V, the magnitude of the impulse, right? Initially, to one direction, you can apply principle of linear momentum conservation. So before the collision is 0.6 into V plus 0.9 into minus 2, because it's minus 2 because it is the other way around, but we consider this direction as positive, right? Is equals to 2 times of minus 2 plus 0.9 times of, so this is not 0.2, it should be 0.6. I just made a mistake.
0.6.
Yeah, it should be 6. Six into minus 2, because it's minus 2. The reason is that that one also turn to the other way around into 0. Right. With this, you can say 0.6 V minus 1.8 is equals to minus 1.2 plus 0. So with this 0.6 V is turned to this side, brought to other side is 1 minus 1.2 plus 1.8, it's 0.6. V equals to 0.6 divided by 0.6. So V become 1 meters per second. Then they ask, this is situation here, part B, the magnitude of impulse exert on A by B. A is here and B is here. So if you collide, always impulse comes towards the object I. So you can put this side I equals to M, sorry, I equals to mass times of V minus U. Final answer is initial velocity. Mass of A is 0.6. Now we consider this side as positive, but the V. Final velocity is the same side, it should be plus 2. Minus initial velocity is to the opposite direction 1. Minus 1. So this is turned up to 0.6 into 3, it's 1.8 kilogram meters per second would be the answer for this. That is the condition where we should know about when you're answering this question. It's a way of doing it. Right. A vertical ball thrown vertically upward with the speed of 20 meters per second from point A, which is h meters above the ground. Right. Okay. So it is thrown from kind of a platform. This platform is h meters above the ground. From this end, you project an object vertically upwards at a speed of 20 meters per second. 20 meters per second. Therefore, it follows up a path somewhere like this and it will fall. Right. The ball moves freely under the gravity until it hits the ground at 5 seconds later. When you reach the ground at t equals to 5. For the total projectile, the initial speed is upwards 20. Acceleration is downwards 9.8. This is a point you have to understand, right? Then time is 5 seconds. We need to find what is h, what is s. The displacement is the one we need to find it, sh. This is the problem where we need to find it. Therefore, I will apply upwards sc equals to ut plus half at squared. Then u is 20 times of 5 plus half into, this is minus 9.8. The reason is that this is downwards, but we consider upwards as positive, into 5 squared. If you substitute it, you get the answer S. S means actually H is equals to 20 into 5 is 100 minus 0.5 into 9.8 into 25. Minus 22.5. H become minus 22.5. Obviously, that is correct. What do you mean? Because the point it reached the ground is vertically below the initial point, and we consider upwards as positive. So you can say H is 22.5 meters. That's a way of writing the answer for this. A second ball is vertically thrown downwards the speed of W from A moves freely under the gravity until it hits the ground. Okay, so I'll just mark the second fact of it. It's turn up to, it's thrown downwards the speed of W, this one. W, and from freely under the from A moves freely under gravity until it is the ground. Okay, the first ball hits the ground with the speed of V, and the second ball hits the ground with speed of 3/4V. Find the value for W. Let's go ahead with this. Right. Okay, this is the way of getting it. So now to answer this question, initially we need to find the speed of first ball when it reaches the ground. Velocity of the first ball reach the ground. Reach the ground. Then we know that U is upwards 20, A is downwards 9.8, T is 5. We need to find the value for V. So we can apply upwards. V equals to U plus AT. Then U is 20 minus 9.8 into time is 5 seconds. So you can say 20 minus 9.8 into 5. It's minus 29 meters per second. Minus 29 meters per second, right? That is the speed of the first ball reach the ground. But according to this statement, the second ball reached the ground at 3/4 of the first value. Therefore, we can find out the velocity of the second ball when it reached the ground. Velocity of the second ball reach the ground. Reach the ground is equals to minus 29 into, according to this one, it's 3/4. Yeah, 3/4. That is turn up to how much? I'll keep this minus format over here. Later on, I'll mention that what do you mean by this minus?
21.7.
21.75. Minus 21.75 meters per second. That means this minus indicates you it's downwards 21.75 meters per second. Now for the second ball, let's go ahead with this. The fact they want is find the value for W initial speed. Now what are the information we know about this motion? For second ball, you know that U is the one we need to find it. That's a problem, we need to find it. S value we know, it has traveled for a distance of 22.5 meters. That is downwards. V, final velocity is downwards 21.75. Acceleration is downwards 9.8. Since all the facts are downwards, we can apply downwards. V squared D equals to U squared plus 2AS. V squared is 21.75 whole thing squared is equals to U squared is the one we need to find W squared plus 2 into A is 9.8 into S is 22.5. With this, you get the answer. W squared is equals to 21.75 squared minus 2 into 9.8 into 22.5. That is, yeah, 32.0625. With this, you get the W is equals to the square root of that. Yeah. Start how much? 5.66 meters per second. 66 meters per second would be the answer for that. That's a way of getting this kind of a question. Yeah. It's a way of understanding the situation. Right. So when you're starting this question, the initial will start the question in this way. The particle of P, a particle P of mass 1 kg is placed. So as soon you get it, you can mark the weight. Weight is 1.5 kg. So in this case, you need to see whether the G value is 9.8. If you have in doubt at the beginning of the instruction sheet, you can see this figure. So you can say that that is mass is 1.5 into 9.8. That is the weight. So initially we will get that answer. That is 14.7 newtons per day. Right. Then, so from this case, start this question in this way. You just get the component parallel to the surface and perpendicular to the surface. We already learned from this component is a sine component, 14.7 sine 30, and this is 14.7 cos 30. And the reaction comes to this side. Usually the reaction may involve if the surface is rough only. Other than that, it won't make an impact on this one. Right, okay. This much. The coefficient of friction between the P and the plane is 0.6, show that P rests in equilibrium. Right, okay. So in this case, if you apply, right. So in the first part of the question, right. Here, this object is in equilibrium. This X is not there for the first part of the question. This is not in all. This is the answer for the second part of it. Initially, if you keep it over here, it tends to what we call slip into this side. Slips into this side. Therefore, the friction comes to this side. The coefficient of friction is 0.6 R would be the value for that. Right. Initially, let's see how to show this, but it's in equilibrium. Initially, we need to find out what is the reaction force. That is what we need. That purpose is to identify the mu R value. Right. So we can say 14.7 sine 30 would be the value similar to R. Therefore, R is equals to how much? 14.7 sine 30. That is 7.35 newtons. 7.35 newtons. That's the reaction. Then we can find the maximum friction. Maximum friction. Over here, the coefficient of friction of plane 0.6 means this is a maximum friction. It can, what you call the surface can occur on an object. Is how much? That is mu R. Mu is 0.6, R is 7.35 into 0.6. So that value is 4.41 newtons. 4.41 newtons. Then we will get the downwards force. Downwards, what is that force? It's 14.7 cos 30. Let me see the value for this. 14.7 cos 30. That is 12.73. The particle of mass 1.5 kg. It's 12.73 newtons per day. We'll see whether there's some kind of an issue I can see. Because let me see the frictional force again. We'll just go a little bit of it. Because we need to show that the friction frictional value should be greater than this, the downwards force, then only we can say that it's not slipping with it. We will see where we made the mistake. Yeah, let me see with this. This is R. If V equals to mu r, the frictional force is mu r, and the weight component is cos 30. The particle wave mass of plane within something, the coefficient of friction between the plane, between P and the plane is 0.6. Show that P rests in equilibrium at A. Right. Okay. At A. Okay. So there is no other forces acting on it. One second. Have we made any mistake over here? Let me see. The weight component is 1.5 into 9.8. 1.8 to 14.7. 14.7. I made a mistake here, but this is the point. The components are wrong. The components which I made, the components wrong, but this is not sine component. This is not cos component. The opposite around. I just made the, that's the point where I made the mistake with it. So we have to do it from the beginning. Sorry, it's my mistake. We'll do it again with it. So this is actually this is the sine component with it. This is sine 30. Sorry, this is the cos component, and the other one is a sine component with it. This is cos 30. Cos 30, and this is sine 30. Sine 30. But in this case, R is equals to how much? 14.7 cos 30. 14.7 cos 30 is, that is 12.7. Yeah, 12.73 newtons. Then we can find the frictional force. Maximum friction. Maximum friction is mu r. Mu is 0.6. R is 12.73. So the maximum friction is 7.638. 7.638 newtons, right? That's the maximum friction where we can occur. Then what you can get here is the downward force. The downward force is how much? 14.7 sine 30. That value is how much? 14.7 sine 30. That is 7.35. 7.35 Newton. So downwards force is 7.35. That force is not large as a frictional, but frictional force is bigger than the force downwards. Therefore, the friction can keep this object remain stationary. So you can say, since the friction is bigger than force downwards along the plane, object does not slide down. That's a factor to understand, right? Then the next one. Okay, after all of these things, right? I'll just these two forces should be there. R we need, and the friction force we'll keep it for a while. Just after we know these facts, right? A horizontal force of a magnitude x Newton is applied to P as shown in figure 1. The force acts on the vertical plane containing the line the greater slope of the inclined plane. The particle is now point of moving up the plane. So now you can see from here, if this angle is 30, this angle also turn up to how much? This angle also turn up to 30. Therefore, the two components, x component, it comes to this side, and it comes to this side. This is x cos 30 and this is x sine 30. Right. Okay. That is a fact we have to understand today. Now this is point of slipping upwards. Therefore, the friction comes to this side today. Now the friction comes to this side, that is mu r. It goes to this side, right? Find the magnitude of the normal reaction force of plea and the value of x. It's a kind of 7-mark question. Now let's go ahead with this. Initially, I'll consider the forces perpendicular to the plane. I'll consider the forces perpendicular to the plane. I'll just make it a little bit of small, then I can see the entire question at once. So this force R, upwards force is equals to how much? Downwards forces. X sine 30 plus 14.7 cos 30. So it's turned up to R is equals to 0.5x plus 14.7 cos 30. I think we already got this answer before. 12.73. Yep. 12.73. So from here you get the equation R minus 0.5x is equals to 12.73. I'll keep this answer as my first equation. This is 7 actually. Then we'll consider the upwards equilibrium. Sorry, along the plane equilibrium. This is the force only there. X cos 30 is equals to how much? Downwards forces. What are the downwards forces? 14.7 sine 30 plus mu r. Right. We'll go ahead with this. This is x cos 30. Cos 30 is root 3 over 2x is equals to 7.35 plus mu value is 0.6. That's the maximum friction into r. Right. But from here you can make the second equation. What is it? I'll bring this 0.6r to other side. Minus 0.6r plus root 3 over 2x is equals to 7.35. This is my second equation. From here you can get the value for r and value for x. We'll work out as a simultaneous and you can obtain the answer for this. The first answer is 1 minus 0.5, 12.73. Second one minus 0.6, root 3 over 2 and 7.35. You work out with this, you get the answer for R. R is 25.97. 25.97 newtons and X value. X value become 26.48. 26.48 newtons would be the value for that. That's the way of getting this answer. Right? That's how you need to answer this kind of a question. Yeah, this is the way. Right. A plank AB of length 6 meters and 4 kg is given. The length and the mass still in equilibrium horizontally for 2 supports at C and D. These dimensions are given, but still we don't know whether this rod is a uniform rod or non-uniform rod. If it's a uniform rod, we can mark the center of gravity at the exactly midpoint of 6 meters, 3 meters from each side. Right. A brick of mass 2 kg rest on a plank at, a brick of mass 2 kg rest on a plank at A. So over here, you can mark this weight. 2 into 9.8. That is 19.6 newtons per day. And a mass of 3 kg rest on at B. So it's turned up to 3 into 9.8. This is 3 into 9.8. It's equals to 29.4. 29.4. 29.4 newtons, right? These are the forces acting on here, right? The plank is modeled as a uniform rod. If it is a uniform rod, the center of gravity works at the midpoint. It is 4 kg, that is 4 into 9.8. It's equals to 30 9.2 newtons per day. Yeah, sorry. Yeah, this 39.2 newtons per day. The Planck is modeled as uniform. Find the magnitude of the reaction at experts on C and D. So we can mark the reaction over here RC and reaction at D over RC. Then to find this, what can I get here is initially I'll consider the vertical equilibrium. Vertical equilibrium is upwards forces equals to downwards forces. Equals to downwards forces how much? 19.6 plus 39.2 plus 29.4. So you can say RC plus RD is equals to 90. Yeah. How much is it?
8.2.
Yeah, 8.2. 8.6 plus 0.2 plus 9.4. It's 88.2. Yeah. 88.2 newtons, right? Okay, we'll keep this answer. Then to get this answer, let's say what we can get here is that we know two unknown facts are there. Therefore, you need another equation. To get that, I'll consider the moment around A. Then if you consider the moment around A, these three forces produces a clockwise moment. And these two produces an anti-clockwise moment. Let's start with that. From A, 19.6 into, from A to A, the distance is 0 because we consider the moment from A, plus this one. 39.2 into the distance is 3 meters per day. Over here, it's midpoint because you know the center of gravity is at the midpoint per day. And plus 29.4 into the distance is per day, totally 6 meters is equals to anti-clockwise moments per day. Here the distance is 2 into RC, 2 into RC, and over here to here, A to B the length is 6, therefore this length is 1 meter, means from A to D would be how much? Only 5 meters, 5 RC. We can work out this, so you get this answer, 39.2 into 3 plus 29.4 into 6. That one is 294. So you can say 2RC plus, sorry, 2R, just 5RD. So this is not R6, it should be 5RD. 2RC plus 5RD is equals to 294 newtons per day. From this you can get the, by solving these two as simultaneous equation, you can obtain the answer for RC and RD per day. Right. So in this case, it's turned up to 1 and 88.2, 88.2, and it's 2, 5 and 294. Then RC turn up to 49 newtons and RD turn up to 39.2 newton. 0.2 newtons. That's a way of getting it. That's the first part of the question. Right. Part A, 1 and 2. Right. Then what they mention here is a 3 kilogram brick is now removed and placed with a brick of mass x kg at B. Now what you can understand here is, now this is not there anymore. They mention the 3 kilogram brick is removed from and replaced with brick of mass x at B. So over here, now it's turned up to how much per day? So I'll just use a different color to represent that. Now it's not 3 is not there, it's x. So it's turned up to here x into 9.8. 9.xx is the value for the here. Right. The plank remain horizontal and equilibrium, but the reaction on plank C and D are now equal. Now there is nothing called RC and RD. Both of them are R. Now both of them become R because they are equals to each other. The fact is to find the value for x. So yeah, this is pretty simple. Again, we will consider upwards forces equals to part B answer, upwards equilibrium. So we can consider upwards forces equals to downwards forces. If I just type a little bit of small, yeah, upwards forces are R plus R, 2R is equals to downward forces are 19.6 plus 39.2 plus 9.8x. This is my first equation. I will simplify this and keep it. It's kind of easier for me to simplify. Then 19.6 plus 39.2. It is 58.8. 2r plus 58.8 plus 9.8x. I'll keep this in this format. Later on we can do the transitions for this, right? Then I'll consider the moment around A. If you consider the moment around A, you can see these three produces clockwise moment, whereas these two produces anti-clockwise moment. So you can say 19.6 into 0 plus 3 times of 39.2 plus 6 times of 9.8x is equals to 2 times of x. So 2 times of r, I'll get it as r. 2 times of r, there's nothing called x. I just process is not x. So that will be misunderstanding. And here to here, the distance is a to d. Distance is 5 into r. Right. From here, you can obtain this equation 0 plus 39.2 into 3. That is 117.6 plus 58.8x is equals to 7r. The from these two, I can produce two different equations from, okay. From first equation, I'll just make like this, 2r minus 9.8x is equal to 58.8. From here, you can say 7r minus 58.8x is equals to 117.6. By simplifying this to a simultaneous equation, you get 2 minus 9.8, 58.8. 7 minus 58.8 and 117.6.
47.04.
Then what is that answer for? Yeah, the first fact is for the reaction R. R is 47.04.
3.6.
Then the other one is 3.6. Therefore, X is equals to 3.6 kilograms. That's the answer for this. So just go ahead with this and make a view of this. Yeah, this is the final answer for this. But 1 second. Yeah, this is the answer for that. A boy B is running in a field with a constant velocity of 3I minus 2j. At time t, this is V is given here. V, sorry, just blue color for this. V. At time t equals to say B is at a point with a position vector of j. This is Ri. This is Ri initial position. J I component is 0, so the j component is 10. So this is what it happens with it. And V you can write 3 minus 2 in a column matrix form. If you write the column matrix form, it's easier for you to simplify this with it. Then find the speed of B. You can find the speed of any kind of a vector component from velocity, the modulus of velocity. That is, you can say 3 squared plus minus 2 squared, all thing, I'd put the bracket over here, the square root of it. That is root 30. That's the answer for that. The direction of B when it's running, giving answer in a bearing, right? Okay, let's go ahead with this. But this is the way. I just do it here to save some space. You can understand that, but this is the diagram. Along I component, it's 3. Along J component, it's 2, minus 2. That means what we need to get here is This is what we need to find it. We need the angle as a bearing. Bearing should be measured from north clockwise. So this is 90. Then if you find this angle theta over here and you find it, you can get this answer very easily with it. Right. So I'll just do it here. The answer for this part is, if you draw a triangle over here, we know that this is the angle we need to find it. This is 3 and this is 2. No need of considering the negative for that because we need only the angle, right? So we can say tan theta equals to 2 over 3. With this, you get the answer t equals to tan inverse 2 over 3. Right. Shift tan inverse 2 over 3. 33.69 is the angle for that. Therefore, the total bearing should be 90 plus 33.69. Why is 90? Because here the angle is 90 plus this part is 33.69. It is 123.69 is the answer for that. 123.69 degrees is the answer for that. Okay. At time t equals to second, curl G is at a point of position vector this. This is for a second person. It's Ri for the second person is 4 minus 2. Girl is running at a constant velocity of this. So V is 5 over 3 and 2 is the velocity vector for that. Find the value for t when they meet the position vector of p. Let's see, to do this question, a 6-mark question. Then for boy, I'll get the position at t equals to t. This is the way of doing this question. For that, we can apply final position is equals to initial position plus velocity into time vector. For boy, the initial position is 0, 10. And the velocity vector is 3 minus 2 into time t. It's equals to Rf. Right. Then for girl, also we can find the position at t equals to t. So you can apply Rf equals to Rri plus Vt. So the Ri is initial position is 4 minus 2. Velocity is 5 over 3 comma 2 into t. So this is 4 plus 5 over 3t minus 2 plus 2t. Right. Now what you can do? Now you can see if they meet each other, the condition is at the same time they should, what do you call that, I components and j components should be similar. That means 0 plus 3t, 10 minus 2t must be similar to what happened? 4 plus 5 over 3t and minus 2 plus 2t. Those two should be similar to each other. That is the point where we need to understand, find the value for t where they meet. That's all they mention. They mention it's meet, therefore no need of proving it's meet, so you can do it. So you can get the I component or j component, whatever, it's fine, not a problem. 3t is equals to 4 plus 5 over 3t. If you simplify this, you get the answer. 3t minus 5 over 3t is equals to 4. With this, you get the answer for t is equals to 4 divided by 3 minus 5 over 3. The t become 3. Let's work out with the j component and see whether you get the same answer. 10 minus 2t is equals to minus 2 plus 2t. Look over here. 4t equals to 12. Let the t equals to 3. So look at this. Whatever the value you get it, you get the same thing. Then look at the position vector. You can replace this t3 into any of this. Here or here. Doesn't matter. It's wherever you put it. So you can say position. Position is equals to, you can say, I will put it here. I think I'm replacing here. It's kind of easier. This one, this part of it. 0 plus 3 times of 3, 10 minus 2 times of 3. That is 9. 10 minus 6 is 4 is the answer for that. 9, 4 would be the answer for this question. That's a way of getting this answer. Okay, Pate, right. A car starts from rest. This is the important point. At a point A and moving along a straight horizontal road, the car moves with a constant acceleration 1.5 second meters per second, 8 seconds per day. So in this case, definitely we are going with the speed time graph. So I will start to draw it with a initially start with 0. So you can apply it travel at a speed of, so you can apply 1.5 meters per square second for 8 seconds per day. So u is 0, acceleration is 1.5 into 8. It is 12 meters per second. So it's come up to 12 in 8 seconds. Right. The car then moves with a constant acceleration of 0.8 meters per second for another 20 seconds per day. For now, in this case, now this is the u for the next moment. Again, if we apply v equals to u plus 80, this is for the first 8 second, 0 to 8 second, then 8 to another 20 second. That is 8 to 28. 8 plus 20 is 28 per day. So v is the one you find it. Now, at this moment, the initial velocity is 12 per day from here onwards. Another 20 seconds plus a acceleration is 0.8 for another next 20 seconds into 20. Let's turn up to v is equals to 12 plus 28. Let's turn up to 28. Now the gradient is a little bit of a low. Now here the velocity is 28 and the time is also 28. Yeah, it's both are 28. Yes, u is 12 plus 28. Yeah, right. Okay. Constant speed for, sorry, then it moves with a constant speed for t seconds. Another t seconds over here. This time is t, 28 plus t. Before slowing down with a constant deceleration for 2.8 seconds until it stops at point B. Right. Then put the over here, what you can get is, we can find this time as well. How do you find this time over here? Sorry, v is 28. Now here the final initial velocity is 28. Again, we can apply v equals to u plus 18. Now here the starting from 28, they mentioned the deceleration is 2.8. Therefore, it's minus 2.8 into time. V is 0. With this, you get the value for t. T become how much? T become 10 seconds. Then here the time is 10 seconds. So if you add 28 plus t, another t, it's turn up to 38 plus t. Right. Here the time is 20 seconds and here the time is 8. Beyond these facts, right? Find the speed of the car 28 seconds after leaving A. Sorry, 28, let me see the velocity. We already got this answer. That is a part A answer. Sketch the speed time graph for this motion over here. Find the distance traveled in first 28 seconds. That means first 20 second means up to here. That means you need to find the area over here. I'll use a different color for that. This area we need to find it. That one I'll initially get this triangle over here. It's half base into perpendicular, it is 12 plus the area of this trapezium. 12 plus 28 divided by 2 into 20. That's the answer for that. (48). This is 48 plus this one, 12 plus 28 by 2 into 20. It's 400. That is 448 meters. That's the answer for that, right? Then they mention the distance A to B, and for the whole distance is how much? They mention the whole distance is 2 kilometers. Find the value for T. Then you can say 2 kilometers is 2000. It's equals to this area we already found this value 448 plus this area over here, this length is t into height. Height is 28 plus the area of this triangle. This height is 28, half base. Base is 10 into perpendicular height is 28. Then it's turned up to 2448 plus 28t plus 280 is 140. With this you get the value for t. So t become 2000 minus 448 minus 140 divided by 28. So turn up to 50.42 seconds. That's the answer for this. That's the way of doing this question. I'll just a little bit down and get it. I hope this answer is fine. Just let's recap this answer. I think it's fine. Yeah, that's fine today. Right. It's a way of doing it. I just make a page free for this. Yeah, let's see. Just make it a little bit of large. Then you can see it kind of clearly. Yeah, this is a question for them.
Sir, you're mute.
Sorry. Respectively connected. Sorry. Two particles P and Q of mass 2 kg and 3 kg respectively are connected by a light inextensible string. Initially, P held at rest on a fixed smooth plane inclined to 30 degrees to the horizontal smooth plane. This is smooth today. Right. The particle Q hangs in the freely below the pulley and 6 meters above the ground as shown in the figure 3. The part of a string from P and pulley is parallel to the line of greatest of those things. Additional information. For the motion of Q before it hits the ground, show that the acceleration is this and the tension of the string is, we have to find it. Right. Okay. Initially, we will mark the information over here. The mass is 2 kg, therefore we can mark the weight component. Usually, since this is a smooth surface, perpendicular component is not required. So we can mark the weight component along the plane. Along the plane, you can see the final expression given in terms of g. Here show that acceleration is q 2g over 5. Therefore, you can write the mass is 2g sine 30. That is turned up to g. Sine 30 is half, 2.5 get cancels. And the tension comes to this side. And here the tension also this side. And this is T this side and tension here is this side. And here weight is 3g. Right. Then we need to find the acceleration. Then you can say if you put it over here, this goes up with an acceleration A and this goes down with an acceleration A. Then for P, I can apply along the plane F equals to ma. So it's moving up. Therefore, you can say T minus G is equals to mass is 2 into A. This is my first equation. Then for Q, downwards F equals to ma. That is 3G minus T is equals to minus T is equals to 3A. This is my second equation. Right. Then if you add these two together, 1 plus 2, what do you get? 3G plus minus G is 2G is equals to 5A. Therefore, A is equals to 2G over 5. I think that is the fact where we need to get from this answer. Answer part 1 answer. Right. So this is A part 1. Then part 2, if you want to find the tension, we can use any of this equation today. You can write from 1. From 1, you can say T minus G is equals to 2 times of A. 2g over 5. Therefore, T is equals to 4g over 5 my plus g. That is T is equals to 9g over 5 would be the answer for that. 9g over 5. That is the answer for part 1, part A, 1 and 2. Right. Okay. Then they mention, right. On hitting the ground, Q immediately brought to rest by impact. Find the speed of P at the instant where the Q hits the ground. In its subsequent motion, P does not reach the pulley, right? Okay, so hitting the ground Q immediately before they come to rest, find the speed of P at the instant where Q hits with the ground. So this is pretty simple question. You know that, but here the acceleration. I'll just write the answer part B over here. Acceleration is 2 over 5g. 2 over 5g is 9.8. So the acceleration is, it's 3.92 meters per square second. Meters per square second. With this, you can say, we know that initial speed is 0. We need to find the final speed. Acceleration is 3.92. It traveled for a distance of 0.6. We need to find the value for v. So we can apply v squared d equals to u squared plus 2as. U squared is 0 plus 2 into 3.92 into SS is 0.6. With this, you get the value for v. 2 into 3.92 into 0.6. That is this bit and the square root of that answer. It's turn up to 2.17. 17 meters per second would be the value for that, right? Okay. Okay.
So you are mute.
At the subsequent motion, P does not reach pulley. That means it does not come and hit with the pulley. Find the total distance moved up the plane P before it comes to internal rest, and find the length of the time between Q hitting the ground and P first comes to internal rest. Right? Okay. This is the point for that. Now you can see, now this Q comes to this point. Now Q is over here. Now the Q is over here. Then P has traveled for 0.6 meters up. Because when this Q goes, because the same motion, it travels for 0.6 meters up. Now at this point, Q has a speed, because you know that the speed where the Q has is the same thing as the P contained at this point. The reason is that both of them are joined with the inextensible string. So here the speed is 2.17 meters per second. Right now, the tension is not there in the string. It's just like this. It's like that it comes. Then, in subsequent motion, P does not reach the pulley. Find the total distance move up the plane P before it come up to instantaneous rest. Right? Okay. We'll try to answer this question today. Now Q is, sorry, if you come over here, P is on this plane. What is the speed over the P? P is 2.17 meters per second. U. For this one. So at this moment, it comes like this. Now it's moving. Now the tension is not there, means now the acceleration is not the acceleration which is already at the beginning, because they are now this acceleration we found under the weight component and the tension component both. But here now the tension is not there. Now let's see what is the acceleration for this. It is undergo a certain force over here. This force is only this bit. It's 2, and we know that angle is 30, so it's turned up to mass is sorry, I think mass is 2. Yeah, that's right. Now the force over here is how much? 2 into 9.8 sine 30. This is the force. This is the only force acting on this object. So you can say 2 into 9.8 sine 30. That is 9.8 meters per second. Sorry, Force is 9.8 meters per second. Now this is running under deceleration due to this force. So can find the deceleration over here. Force is 9.8, mass is 2, acceleration. So it's actually this is not acceleration, it's deceleration because it's opposite direction of the motion. Now for the subsequent motion, u is 2.17. A is minus 4.9 until it come up to rest. Sorry, total instantaneous rest. V is 0. We need to find what is S. So we can apply V squared D equals to U squared plus 2A S. So the 0 squared is equals to U squared is 2.17 squared plus 2 times of A is minus 4.9 into S. S is the one we need to find it. From here you get the answer for S is 2.17 squared should be divided, 9.8 is equals to 4.7089. Therefore, S is equals to divided by 9.8. So that is 0.4805 meters. Now at the beginning, it was traveling for 0.6 meters. Should we add another 0.6 meters to this at the point? Because they asked what is the total distance traveled today. So it's turned up to 805 10 point this bit meters, right? Then find the length of the time between Q hitting the ground and P first come up to rest. Hitting the ground is point over here, the same thing over here. So for part D, we can apply V equals to U plus AT. V is 0 and until come up to rest, U is 2.17. Acceleration is deceleration over here, minus 4.9 into T. So with this, you get the value for T. 2.17 divided by 4.9. That is 0.44 seconds. That's the answer for that. That's the way of getting this. Right, okay, let's go.